Hello, welcome to K2 Concept YouTube channel. And with you is Dave Komen. And I'm going to be explaining one of the important concepts in differentiation, which is known as the quotient rule. In my previous video, I explained how to use the product rule. So today we're going to be explaining how to use the quotient rule. Now, from the word quotient means division. So, if I say two functions dividing each other and I'm asked to differentiate, that is, I'm asked to find the derivative of this function, then the appropriate rule to use is the quotient rule. Now, the formula for the quotient rule is the y dx equal to v d u divided by the x minus u the v divided by the x over v squared. Now we're going to look at three examples to illustrate the quotient rule. The first one is y equal to cot x. Now, cot x can be obtained from the table of standard derivative, but we're going to apply the quotient rule to solve this problem. We recall from our knowledge of trig identity that cot x is equal to 1 over tan x. But also we know that tan x is equal to sin x over cos x. So which implies that cot x is equal to 1 over sin x divided by cos x. So if you perform this arithmetic, you're going to have 1 multiplied by cos x over sin x, which will give us cos x over sin x. So it means the original question can be transformed to cos x divided by sin x, which is a quotient rule problem. And for quotient rule, you should select your u. The numerator is the u and the denominator is our v. So we say u equal to cos x, then v equal to sin x. Now, after selecting the u and the v, the next thing to do is to obtain the derivative of u and the derivative of what? Of v. So differentiating u with respect to x, that is cos. From our knowledge of table of standard derivative, if cos is being differentiated, we obtain minus sin x. And if we do the same thing for the next function v, the v with respect to x will get cos x. Now, after obtaining this result, the next thing is to write out the formula of quotient rule. And the formula for quotient rule is dy dx equal to u dv dx, v du over dx minus u dv over dx over v squared. Now we have to substitute the result we got above. So our v is sin x, then our du dx is minus sin x, then minus our u is cos x, then our dv dx is cos x, divided by v. Our v is sin x, so sin x all squared. So we have to simplify this. We said dy dx will give us sin x times sin x. Remember, in my previous video, I explained how to arrange this. We said the sign comes first, then followed by the constant, followed by the power function, followed by the exponential function, followed by the logarithmic function, and thereafter the trig function. But here we are having two trigonometric functions. So the sign comes first, then sin x times sin x is the same thing as sin square x, which means if I have sin x and I have sin x, applying this, is the power here is 1, the power here is 1 to give us sin 1 plus 1 of x. If you add these two, we have what? Sin square x. The same thing happens here. We have cos square x over. Now, the power of sin here is 1. From the law of log of indices, we know that log indices say if I have two power multiplying each other, this the 2 becomes a times b, and that's what's happening at this point here. So 1 times 2 will give us 2. So this is sine square x. And we recall also from trig identity that sine square x plus cos square x equal to what? 1. So from this we have minus sine square x plus cos square x equal to sine square x, because we know that minus is common to both sides. So from here, applying this knowledge of trig identity, this becomes minus 1 over sine square x. Now this might be our final answer, but we also recall from knowledge of trig identity that if we have sec x, we said sec x is the same thing as 1 over cos x. And we said cosec x is the same thing as 1 over sine x. Which means if I'm having 1 over sine square x is the same thing as cosec square x equals to 1 over sine square x. So it means that dividing x to this problem will be minus 1 over sine square x, which is equal to minus cosec square x, because this will give us cosec square x. That is the result for the first example. Now we move on to the second example, which says y equal to tan x. Now in the previous example we explained, we said tan x can be written as sine x over cos x. So which means y is sine x over cos x. So apply the same thing. Since it's a product rule problem, our u is the numerator and our v is the denominator. So which means u equal to sine x, then v equal to cos x. Then du dx will give us cos x. Then the v dx will give us minus sine x. Applying the formula for quotient will give us the y dx equal to v du dx minus u dv dx over v squared. Now what's our v? Our v is cos x, and our du dx is also what? Cos x, minus our u is sine x, then our dv is what? Minus sine x over v is cos x or squared. Now, if we multiply, following the procedure of the first example, we have this to be cos square x, applying indices. Minus times minus here will give us plus sine square x over cos square x. We also know that cos square x plus sine square x will give us 1. So this problem reduced to 1 over cos square x. And we have said, or we have established this fact earlier, that from trig identity, that 1 over cos square x is the same thing as sec square x, since sec x is the same as 1 over cos x, then 1 over cos square x will be the same thing as sec square x. Now, this result will now be the y dx becomes 1 over cos square x, which is equal to sec square x. That is the solution to the second example. Now, moving on to the third example, this is a different aspect. We can see that a polynomial function is dividing a trigonometry function. So to solve this problem, it's a quotient rule problem, but it's quite different from the two examples solved earlier. Now going back to this question, we said y is equal to 3x squared plus 4x minus 1 over sine x. Now the same way, we said I will select our numerator as the u, then the denominator as the v. So it means u equal to 3x squared plus 4x minus 1, then v equal to sine x. We have to differentiate. Now, to differentiate, in a previous video, I explained how to differentiate power function, that is polynomial function. I'm still going to explain it again for those that have not watched, but not in detail. So if you want to get more detailed and more comprehensive explanation rather on this, you can watch my previous video. Now, if I differentiate this with respect to x, it means the power will come down to multiply this, it becomes 6x plus the power of x here is 1. So 1 multiplied by 4 will give us 4. And 1 minus 1 is 0. So anything raised to the power of 0 is what? Is 1. So 1 times 4 will give us what? 4. Then here we are seeing that 1 is not having x. And in my previous video I said, if it's not having x, it means it's a constant. So when you differentiate a constant, the result will be what? 0. So our answer will be 6s plus 4 minus 0. So anything in this life minus 0 is still that thing. If I say 4 minus 0, it is 4. So that is why we don't need to write anything here. So dv over dx from 3, if we differentiate sine x, it gives us what? Cos x. So applying the formula of quotient 2, we have u dv dx minus u dv dx, then v squared. So now, our u is sine x. Our du dx is 6x plus 4 minus our u is 3x squared plus 4x minus 1. Our dv dx is cos x. Everything divided by v, and the v is sine x all squared. Now, in this case where we are seeing trig function and a polynomial function, most students find it difficult to know what to do from here. And I made it so easy in the previous video that we have to arrange. And the arrangement pattern is very simple. We said the first thing that comes is a sign, which is plus or minus. Then followed by your constant. Then followed by the power function, which are represented as pf. Then followed by the exponential function, which are represented as ef. Then followed by the logarithmic function, and lastly the trig function. That's the arrangement pattern. So if you follow this arrangement pattern on this part, we will see that trigonometric function and power function, the one that comes first in the arrangement is power function before trig function. So this becomes 6x plus 4 sine x. Then on this other part, we see that minus sign, as sign comes before any other function, so it becomes minus. Then between these two, power function comes before trig function. You have 3x squared plus 4x minus 1 cos x. Everything divided by sine squared x. Now this is the result for this problem. Now, as I said earlier on, this is K2 Concept YouTube channel. Please don't forget to subscribe, like, comment,